Hello, my name is Matthew Tyler, Director of Strategic Business Development at ON Semiconductor. Increasingly stringent fuel efficiency regulations and growing environmental considerations have begun to force many simple mechanical systems within vehicles to evolve into electrical alternatives. This evolution is enabling the next generation of more efficient, higher performing cars. DC motors are at the forefront of bringing oil, coolant, and fuel pumps that reduce drag on the motor, reduce weight, and improve fuel economy. The next generation of gas and diesel engines will have electrically driven forced induction systems that dramatically improve torque and power delivery characteristics well beyond what we currently see as possible for traditional engines. Today, every gram in a car is scrutinized through the design process to improve efficiency and vehicle dynamics. Even small reductions in drag, weight, or other efficiency enhancements pay large dividends to the end user. The latest brushless DC motors are lighter, more powerful, and more reliable than their less sophisticated brushed DC predecessors. The main disadvantage of the Bldc motor has been the cost and complexity of the motor driver. However, the cost of advanced motor control electronics has been rapidly improving over the last few years. These advancements in Bldc motor technology are accelerating the migration away from less reliable and inefficient brushed DC motors. Conventional DC motors need brushes and a commutator to transfer energy from the electrical system to the coils that drive the motor. This is a simple way to make a motor turn, but these components are far less reliable and also create a lot of acoustic and electrical noise. As cars become more advanced with in-vehicle networks, Wi-Fi, Bluetooth, and many other forms of connectivity, sources of electromagnetic noise and interference must be aggressively managed. In addition, conventional DC motors can consume 20 to 30% more electrical power to accomplish the same job. When automotive engineers demand lighter, more efficient solutions and their customers demand more efficiency, performance, and refinement, that choice is clear. As cars become more efficient and advanced, power steering, radiator fans, fuel, oil, and coolant pumps are just a few of the applications that are quickly migrating to Bldc motors. I would like to introduce ON Semiconductor's new STK984-190E, a 30-amp, 40-volt MOSFET power module, which is ideal for three-phase Bldc motor drive applications. The STK984-190E integrates 6 MOSFETs in a three-phase half-bridge configuration, along with the 7th MOSFET for reverse battery protection. With all of the power components integrated into a single package, system design engineers can reduce design time while simplifying PCB layout and improve thermal efficiency. The typical automotive Bldc implementation includes power MOSFETs, gate drivers, sense amplifiers, diagnostics, commutation control, and an in-vehicle network interface. All of these architectural blocks can be easily realized by pairing the STK984-190E with an advanced sensorless Bldc motor driver like ON Semiconductor's LV8907UW. With only 2 components, designers can build high-efficiency Bldc solutions with best-in-class thermal performance, built-in diagnostics, and an ultra-small PCB that saves critical size and weight. The STK984-190E delivers impressive thermal performance as a result of its innovative direct bond copper substrate, which makes it possible for the whole Bldc system to be compact, lightweight, and reliable. Let's take a look at a couple of key advantages. First, this slide shows the comparison of a conventional Bldc implementation and our complete reference design using the STK984-190E and the LV8907UW. The parts count and PCB size has been reduced by more than 50%. With all of the power components integrated together into a single direct bonded copper or DBC substrate, this approach greatly simplifies heatsink and mechanical design while improving thermal conductivity. With the dramatic reduction in board level components, one of the leading causes of reliability issues, which is solder joints, has been significantly reduced. Moreover, the DBC substrate is fully insulated, so it can be mounted directly to a heatsink without the need for additional insulation, further reducing weight, cost, and assembly complexity. This allows the thermal path to be shortened further, improving thermal conductivity, which means less heatsink volume, less weight, and better fuel economy. When compared to a conventional implementation, the STK984-190E reduces thermal resistance by as much as 20%. Let's take a look at how the unique DBC substrate can achieve such impressive thermal performance. This slide shows a cross-section of the DBC substrate. The DBC substrate consists of a specially engineered insulating ceramic with thermally conductive copper layers on each side. The external copper plate is covered with a finishing layer, and the internal copper layer is patterned and used to make a printed circuit. The components are then soldered into place and the interconnect bond wires are used to complete the circuit. Thicker wires and printed circuit patterns are used for the power traces. In addition to better thermal performance, the STK984-190E has been carefully engineered to reduce mechanical stress. Modern cars are designed to survive incredible temperature ranges, and the STK984-190E is more than up to the task. This slide shows the package stress comparison between the technology used in the STK984-190E and a conventional substrate. The test results show our package technology reduces the stress by 50% compared to general DBC substrate implementations. Our package can handle more than 2,000 extreme temperature cycles. This is more than double the number of cycles that a conventional package can survive. Next up, we will show you a simple demo using the STK984-190E. The total control system for this automotive HVAC fan only needs a PCB that is 65 millimeters in diameter. The compact layout greatly simplifies the mechanical design and reduces weight. The result is a high-performance Bldc solution that is quiet, efficient, and does not need any software development, which also means the solution is more reliable and can be used in harsh applications all the way up to 175 C. The LV8907UW is easily configured by setting the one-time programmable, or OTP, memory which holds various parameters. Information is written into the OTP once and transferred to the main register stack at the start of the operation. Therefore, there's no need for an external MCU or other components needed for configuration. The LV8907UW integrates the speed control and many other functions, including a LIN transceiver, which further help reduce the PCB footprint. The LV8907 offers a comprehensive set of system protection and diagnostic functions, such as overcurrent, overvoltage, short circuit, undervoltage, and temperature protection.
In this video, we will briefly demonstrate the capabilities of the Intelligent Power Module along with the LV8907UW. The system is being controlled by our new motor driver development environment. The GUI is easy to operate and very intuitive. The LV8907UW can be controlled in two ways. The first method is a standalone mode where the speed is controlled internally and easily set with an external resistor. If more complex motor speed profiles are needed, then the LV8907UW can be paired with a simple, low-cost MCU that regulates motor speed with only a single PWM to the motor driver. In this demo, the motor driver GUI is interfacing with the microcontroller via USB, which is in turn controlling the LV8907UW. All of the motor driver configuration registers are easily visible and can quickly be set from the GUI, allowing quick optimization of the system. You can also see here that the motor speed, voltage, and current information can be fed back to the GUI for further optimization. The data gathered from the motor can be exported as a CSV file that you can parse and manipulate in the software of your choice.
For more details regarding the STK984-190E, please contact your local ON Semiconductor sales representative or an authorized distributor, or visit us on the web at www.onsemi.com. Thank you very much.